one of the core components of this constellation is onboard compute. And to a certain degree, that is a requirement of the new space economy and also for emerging defense applications like Golden Dome. Ultimately, you have to push compute to the space edge to be able to develop, to drive latency down from observation to action, but also to drive costs down.
Welcome back to the SmallSat Revolution, powered by GomSpace. I'm your host, Frank Felker. I'm joined today by Michael Bartholomeusz, CEO of Novi, creators of the VISTAsat satellite constellation and space computing platform. Michael, welcome to the program.
It's a pleasure to be here, Frank. Thank you for having me.
I'm so excited that you took the time to speak with me today because I'm truly fascinated by what you guys are doing, not only from a technical standpoint, but also your business model, the economics of the marketplace that you're creating. I don't want to get ahead of ourselves here, but there are a lot of reasons why I'm so glad you've taken the time. Let's start, if we may. I almost said at a 40,000 foot level, but I guess that's not appropriate when we're talking about space. But let's start at the top level. Could you tell us what VISTAsat is and what problem it was created to solve?
Certainly, Frank. So VISTAsat is a satellite Earth observation open access platform as a service. And it entails four elements. The first element, of course, is the satellite constellation. And the satellite constellation is designed to have high revisit rates anywhere on Earth to monitor and provide insights on dynamic change. The second element is a broad sensor suite. Ultimately, different use cases require looking at the planet from different lenses. And these include regular RGB, hyperspectral imaging, infrared, thermal infrared, and RF. And so you can look and listen to the world in a myriad of different ways that will inform the different customers and users regarding their use cases. The third element is really computers on board the satellite to process the imagery at the space edge. And this dramatically reduces the cost and latency associated with Earth observation data. And this is as we will discuss later, I hope, Frank, this is a key element to liberating the new space economy. And the final element is a portal and marketplace. And the portal allows enterprises and developers access to the constellation to upload their software and generate the data and insights. And the marketplace is a venue for developers to sell and monetize their applications to a broader user base. So those are the main elements of VISTAsat, Frank.
I'm going to vary from the question set that just throw you a curveball right out of the gate here, Michael.
Right.
Just to follow the 1, 2, 3, 4 pattern that you just mentioned. Now, am I remembering correctly, the first thing you mentioned was the multi-sensor platform. Is that correct?
That is
correct. And you
correct.
did rattle off what the different types of sensors are, but could you go through that again? There's optical and infrared, and what all is included?
Certainly. So there is optical, which is standard RGB. It's the type of camera you have on your mobile phone or on a regular camera. There's hyperspectral. Hyperspectral typically looks at bands from about 450 to 900 to 1,000 nanometers. And, it's very interesting. Instead of having 3 bands at your disposal, you have hundreds of bands at your disposal. And you can really pick up different feature sets because different elements and materials respond to different spectral bands differently. So it's an extremely useful tool in industries like mining and precision agriculture and oil and gas. Then, of course, shortwave IR goes into sort of up to the 2,500 nanometer range, and thermal IR, which goes even further, is useful in forestry and forest fires and tracking thermal features and thermal events on the planet. RF is radio frequency, and that is for applications where, say, you want to listen to ships that have turned their transponders off to look for fishing fleets and other types of activities like that. So this is the sensor suite that we will be integrating into our constellation, Frank.
And all of these sensors are available to your customers. Is that correct?
That is correct. And maybe a slight nuance here. As our constellation grows, our constellation is going to proliferate to about 40 satellites within 36 months. They will have a blended sensor suite. Some satellites will be biased towards hyperspectral imaging, others
Okay.
towards high-res RGB, and a lot of our constellation evolution will be nimble and informed by our customer base and how we onboard our customers and what's important to them. But you're right, all of our customers will have access to the entire sensor suite distributed through the constellation.
Well, as so many aspects of your business do, that makes perfect sense. That as you go forward, you learn from your customers, their needs, their applications, the onboarding process, what's working, what could work better, and making certain satellites more focused on different types of sensors. That's perfect. That's great. Now, was the number 2 point, was that the in-space computing platform?
That is correct.
Okay. Now, you and I had spoken previously a little bit about this. And my understanding from our previous conversation is that this platform, the hardware will be running Linux as the OS, and that your clients, customers, subscribers, can write their own applications to run on the computers. Is that correct? And also, what types of applications might they be creating?
Yes, that is correct. And maybe, Frank, I'll just start with a little bit of a backdrop because I do want to underscore that one of the core components of this constellation is onboard compute. And to a certain degree, that is a requirement of the new space economy and also for emerging defense applications like Golden Dome. Ultimately, you have to push compute to the space edge to be able to develop, to drive latency down from observation to action, but also to drive costs down. So I did want to reiterate that onboard compute is a key element of our constellation, and more broadly is generally recognized as the next level of evolution in satellite autonomy, in satellite commercial performance. So,
well, if you'd like, we can go there. What are the benefits of in-space computing for your subscribers?
So I'll use this from, maybe I can present a couple examples to illustrate this. So consider the first case. If there are events ongoing on ground on Earth that need to be very rapidly observed and acted upon. Today's model, the data is collected from satellites, the images are collected from satellites, all that data is sent down to Earth, that data is analyzed on Earth and then sent to the corresponding asset or the corresponding responding asset. This requires quite a lot of time because there's a long chain of custody. Instead of that, if the data can be collected and analyzed right on board the satellite, the information, the insights, the intelligence can be sent directly to the asset that needs to know, and this dramatically reduces time. Now, in doing that, when you do the analysis on board, it's the classic needle in the haystack problem. The old methodology was you collect the haystack, send it down to Earth to extract the needles. New model, you extract the needles on board the satellite and just send the needles down. When you do that, you're dramatically reducing transmission costs because you're sending far less data down. So this has huge commercial implications in driving down cost of Earth observation, data insights, and intelligence. So that is really the rationale for putting compute on the space edge. It's latency and it's cost.
Wonderful. And does that also save your clients on bandwidth expenditures?
Yes, certainly. It's all a function of what the clients want. Certainly, if the clients want all the raw data for continued analysis on Earth or for, again, some degree of chain of custody, that can be sent down and that consumes more bandwidth. But for example, if the customer just requires the lat-long coordinates of an area that needs action, then you're sending bits and bytes of data down versus gigabytes and gigabytes and terabytes of data. So it's really a question of what the end user wants, what degree of data refinement will dictate what the cost reduction is.
That's wonderful. Now, you had also mentioned to me in a previous conversation that your clients own the intellectual property rights to the data that's collected. Is that correct? And how does that differ from the existing paradigm?
Yes, that is correct. So in today's paradigm, for the most part, the operators, satellite operators, constellation operators will sell images to the end users, but there are significant constraints around that, contractual constraints about the resale of the data, what users can do with the data. So it's a closed access system where there's actually quite a lot of hair in the obtaining and use of data from the operators. And at Novi, we believe that we have to systematically reduce the barriers to the use of Earth observation data if we want to drive adoption, which is why we've taken an open access platform approach. And in the open access platform approach, our customers essentially have a fractional lease. It's fractional ownership, fractional lease of the constellation. And when they task the satellite to get data that they need, they are free to do with that data what they choose to do with that data. So within the bounds of how much they fractionally lease on the constellation, they can collect as much data as they want, and they can leverage that data, they can sell that data, resell it, they can do with that data as they see fit as a result of their fractional lease of the constellation. So it's quite a different business model. We really are driving the transition from closed access to open access from a platform stance.
Well, for those of us who believe in the power of free markets and the invisible hand, what you're creating here, to me, sounds like something that's going to generate a whole new marketplace within of itself, just by letting people do what they want to do, rather than forcing them to try to conform to a particular set of rules. And with that in mind, I just used the word marketplace. I believe your fourth bullet point was the marketplace of apps that you guys are going to allow to be created. Could you speak to that?
Yes, and there's two elements to that. It's one of those beget issues. So for the portals and marketplace to be truly vibrant, to be truly democratized, the only way you can do that is by bringing costs down, and not bringing costs down by multiples, but by an order of magnitude or more. You really have to drive costs down to be able to foster, to promote a vibrant marketplace. And then I'll use an example, Frank. If smartphones today cost $30,000, not a lot of us could use them. And that is to a certain degree the state of Earth observation data and insights today. It's extremely expensive. So the real prolific users of Earth observation data are either medium to large-sized enterprises, or of course, governments and defense agencies. So a key element of this platform that will enable the portal and marketplace is this onboard compute that Novi is able to drive costs down to a level that democratizes the use of Earth observation data. So now, if you look at within VISTAsat, the portal, just consider that a workspace. So different companies and developers, enterprises, they have their workspace. Within that workspace, they can upload applications. These applications are on board the satellite constellation, providing them the insights and intelligence or data that they so desire. For the broader developer community who develops applications, there's a marketplace where they can monetize these applications. They can sell these applications to a user base. And if the costs are low enough, then it's not arduous for a broader ecosystem of developers to develop apps and for users to afford these apps. So this is really our vision for the VISTAsat marketplace. Initially, it will most likely be inhabited by enterprise users, but then we see it becoming increasingly populated by a healthy developer and user ecosystem, very much like app stores for smartphones today.
That's just wonderful. And I look forward to seeing what sorts of apps are created. Right. And just as you guys will adjust what you're developing to your clients' feedback, obviously the app developers will do the same. And I imagine within a very short period of time, there'll be some pretty strong applications on there that people are deriving a lot of value out of.
I agreed, and it's interesting. One of the things we contemplate internally is what sort of apps will be derivative from this platform, and it's really hard to it's hard to predict that. I mean, if we take ourselves back in time to 2008, when the first smartphone apps, app stores became available, I don't think we could have imagined what kind of apps would develop and permeate the fabric of society. And I think we're in a similar stage now with apps as it pertains to Earth observation. And I think one area that could be very productive is the gamification of Earth observation. And if the costs are low enough and access is relatively democratized, and you have high revisit rates where you can look at any part of this Earth every day through multiple different modalities, one could imagine that this becomes a healthy environment for the gamification of space data. And we also think that there will be apps developed for small businesses who today can't afford them. You can imagine companies, pool companies who get dynamic Earth observation data to help direct and target their marketing for new customers. You can imagine, home improvement companies, pavement companies. Who knows? We sit down every now and then and try to imagine that, but I think that the future will inform us where that goes.
Now, in addition to the Earth observation capabilities of the VISTAsat constellation, my understanding is there's also a certain level of space domain awareness that you can offer to your clients as a service. Is that right?
That is correct, Frank. And the just as you have a sensor suite on the satellite, these sensors don't all need to be pointing down to Earth. They can be pointing in different directions around the satellite, and what this enables is space domain awareness. And this has interest for both in the defense realm, but also the commercial realm. And space domain awareness, satellite autonomy, again, for space domain awareness, onboard compute becomes a key element because the one aspect of it is awareness. The other aspect is doing something relative to what's occurring around you. So this can be things like the avoidance of space debris or the characterization of space debris, or in the defense realm, if there is a threat, it is recognizing and responding to that threat. So space domain awareness and satellite autonomy is going to become increasingly important in an ever crowded space world.
I'm sure you're right. It's almost every day, it seems like multiple new objects appear in space that people need to track.
That is
now,
correct.
You have spoken, and I'm very impressed with it, that you're always open to learning new things. But I bet you've learned a lot of things along the way to today. Can you speak to perhaps something either that surprised you or that was quite profound, what have you, that an obstacle that came your way that perhaps you had not foreseen, and how you overcame it and what you learned from that?
Yeah, that's a good question. I think sometimes I think the main obstacle is stumbling upon those things, knowing what you don't know, and the process of learning about what you don't know and overcoming it. I think Novi is fortunate in that regard. A big element of putting up a constellation is really the knowledge set on building satellites, seeking regulatory approval, booking launch, managing mission, managing operations and mission. And in Novi's case, we have already gone through those hard learnings. And that's getting space heritage is an extremely difficult thing to do. And Novi has done this within our defense core vertical. We have assets in space, we have hardware in space. And so that whole aspect of launching and managing a constellation, with those learnings are under our belt. Certainly, as we scale, there'll be operational bumps in the road, as they are for any company. But that's not really going to be an endeavor of discovery. That's just going to be, operational excellence. So, in that regard, a lot of our learnings are already behind us, and we have got a good handle on deploying the constellation. I think some of the learnings that we have gone through are really the nature of the business model, the nature of the industry, how incumbents have enabled this industry and are managing it, and how we believe how we are trying to make it more efficient, more nimble. And that's been a lot of learnings around which industries and verticals need what services, what cost structures are required. So I think we've gone through quite a lot there, Frank, but I really think we need to get a critical mass of customers, which will happen in the next 18 to 24 months. And as we get this critical mass of customers and this biodiversity of customers, there will be a lot of learnings around the business case, how we share capacity, how we share sensors, how this fractional ownership in the constellation or fractional lease harmonizes among a broad spectrum of users, and certainly developing the marketplace, making it user friendly for developers and their user base. So that's where a lot of the learnings are going to derive from. We've already gone through some of them, but I anticipate this is going to be an ongoing process for us as we continually optimize and let the market inform us as to what their needs are.
Well, as you were just doing, what about looking forward? I'm going to ask you to get out your crystal ball here, Michael. And not so much in the space industry itself, but for more terrestrial businesses. It strikes me that what you're talking about and the order of magnitude or orders of magnitude of cost reductions and the democratization of the data and the images and everything you've spoken about could end up having a tremendous impact on existing and nascent and yet to be seen marketplaces here on Earth. If you were able to speak to a room of business leaders, and as I say, more terrestrial business industries, verticals, what would you recommend? What would you advise them to be aware of relative to what's coming down the line in the next 2 to 5 years from Novi?
I would say the benefit of Earth observation data, Frank, is persistence, right? It's persistence over very, very, very large areas, and you have a persistent solution that you can't really achieve with drones or mapping and dynamic change. Of course, we can go to Google Maps and see how things were in the past. But I think if we look to the future and literally in 24 to 36 months, imagine a world, you have a platform where you can look anywhere on this planet every day and start to look how things are dynamically changing over any area, over very, very broad swath sizes, from a few hundred meters, from a few hundred centimeters to a few hundreds of kilometers. So you've got this ever watching, ever vigilant persistence of the world as it dynamically changes on a daily basis. And certainly beyond that, it'll be every 24 hours, every 18 hours, every 12 hours. You drive that revisit rate down. And so you've got this ever vigilant, ever persistent mode of looking at the world around us or the areas of interest to a particular company or a particular developer that provides incredible insights. And to contextualize that, Frank, let's take one use case and talk about the cost implications of Novi's platform. Today, let's say there's a logistic firm or a hedge fund that wants to count the backlog of ships at Baltimore Harbor every day for a year. Every day they want a number, 70, 60, 50, whatever it is, over the course of 365 days. The cost of getting that data for a year today is about $150,000. With Novi's platform, since we do the analysis in space and just send the number down to Earth, it's about $1,500. That's a 2 order of magnitude reduction in the cost of data. So you can imagine when you drive costs down that level, you have the sort of persistence required to monitor dynamic change. It has huge implications on the number of stakeholders who would want to adopt this solution.
And the business leader or business in general not only saves money on the data, but they save money because they're able to make better decisions, faster decisions, decisions that are in direct alignment with real data, not just what they hope is going on.
Exactly.
One other thing that strikes me is sort of the long-term effect of this. As you were speaking, I was reminded of something called the Wayback Machine, which has been tracking websites since the 1990s. And I'm able to go back and see a website, the first website I created back in the mid-1990s, right. As well as every other one I've created in between. Obviously, that's a much longer term and longer horizon, but it speaks to me, at least, of unintended positive outcomes from your network. Now, I feel like we've covered a lot of ground, Michael, but I always like to ask my guests before we sign off, if there's a question I should have asked you that I haven't, or if there's something that's come to your mind that you'd like to share before we go.
I think probably on the more prosaic realm, Frank, as it pertains to Novi and our VISTAsat platform, I think maybe the one question would have been around the timing of the launch of our platform and the timelines for customers to access the platform. So Novi, as I mentioned, in our defense sector, we already have assets in space, and our defense core business is growing and is vibrant. Our commercial space business, we launched that endeavor last summer, and we will have our first commercial satellites up in the next 9 and 11 months in Q1 of 2026. We've already booked passage on SpaceX Transporter 16 and 17, so our constellation goes live within the next 9 to 11 months. In the interim, we are onboarding customers into an emulator environment, and this uses the same backend we will have in space. But what it allows our initial customers to do is to train their inference models. So then when our constellation goes live, they can seamlessly upload these inference models onto our constellation. And it's very much like a flight simulator as a prelude to getting into the real aircraft. So certainly if there are users or developers or enterprise customers who are interested in the VISTAsat platform, please reach out to us. We are onboarding customers as we speak, and the initial customers will be able to go live in the next 9 to 11 months.
And your website address has been shown throughout this interview, and I'll also have links to it in the comments for this episode. Is there any other direction that people should use to reach out to you guys?
I think the website is the most efficient, Frank. It has a good compilation of the information we discussed today. The contact there would be the most efficient way to get through to us.
Great. Well, Michael Bartholomeusz, thank you so much for joining me today.
Frank, it was a delight talking to you today. Thank you very much for your time.
Thanks again to Michael, and thank you for joining us. Until next time, I'm Frank Felker saying, I'll see you in space. The SmallSat Revolution Podcast is powered by GomSpace, with platforms, components, systems, and services to meet every SmallSat requirement. GomSpace brings their innovative technologies and a flight heritage of over 2,000 successful deployments to your next mission. GomSpace, leading the SmallSat revolution. Learn more at gomspace.com.